So visualization, right? We do have some good understanding about this thing because we did discuss some of the charts, right? So in categorical data, we can go with the bar chart. So hope my voice is clear and loud. So in case you need to increase my volume, please tell me. It's fine, right? Okay, thank you. So for bar graph, okay, we can go with the categorical data. Okay, so like histogram, but with the gaps between bars, useful for showing two samples side by side. So hope we are having very good clarity on this, right? So in case we have x and y, right, and also plotting, I think we are very clear, right? When we go with x, y, or we can go with y and x based on the scatter plot or whatever of a plot. So for continuous data, we go with histogram or box and whisker plot. A single variable visualization. Histograms can show center, variability, skewness, and modality. So here outliers or strange patterns can also be found out because you can see here in the extremes, you can see the number of values that is being populated. So bin width and position matters can also be used, okay, in this particular type of an visualization. And beware of real zeros, right? The real zeros in the sense, right, because you're having no gaps between the bars, right? So what could be the issues with histograms? So for small data set, histograms can be misleading. So small changes in the data, pins or anchors can deceive. Okay. So okay, how do we say this? Okay. So in case we say that for small data, histograms are misleading, what are we trying to interpret here? Are you able to understand this issue related with histograms? Why we say that for small data, the graphics may be misleading. It's once again based on particular data set, right? So if in case it's very small, okay, even though if it's distributed, right, we're not very clear with what is the values, right, that's being populated, because we say that it is showing all different types of variability, and the real zeros and outliers can also be detected when we have good number of samples. So when we have large samples, please make use of histograms. For large data set as such, histograms can be quite effective at illustrating general properties of distribution, right? So it can give us very good clarity about outliers and all such things. Histograms effectively work with one variable at a time, but small multiples can be effective, right? So I'm sure all of you are able to understand. This is the reason why we say that it's good for binning, right? That is the reason why we put frequency at our y-axis and a particular attribute in our x-axis. Whereas in that's not the case here. Talking about the bar graph. Bar graph we have can use two samples side by side, right? Okay. Are we clear with this? So in box plots, a way to graphically portray almost all the descriptive statistics at once. So in box plot, we can use upper and lower quartiles, mean, median, range, and outliers. So in box plots, we have a way in which we can identify the outliers, right? I think we did discuss some details. This is just for our own classification and clarification. How we go with different types of graphs, right, for visualization. Hope everyone is clear in this. So the index of qualitative variation, so for normal variation, and what are we trying to do with getting those data points as such into our IQV. So statistics for determining the dispersion of cases across categories of a variable, and ranges from 0, which is a no dispersion or variety, to 1, which is a maximum dispersion or variety. And 1 refers to even number of cases in all categories, not that cases are distributed like populated proportions. Right. So are we clear in this? Good. So by now I think all of you are very well able to draw the graphs, right, with any type of a plotting. To calculate, you can use this formula, but nothing to worry because we already have everything within the scope of the particular code. In case you're going to use R or Python, or even if it's going to be in type of language, you can just use the built-in functions. Right? So the problem, maybe if in case we have a problem to just discuss about diversity of two particular universities, okay, like SJSU and the UC Berkeley, and given some values, like calculate the IQV for each campus to determine which is higher. Okay. So they have given some values, some percentages, and what we can say before calculating which campus is more evenly distributed. So is this example really relevant? Right. So I'm sure that we are able to get some understanding on this particular type of a case study, right? So yes, of course we can use IQV for this type of case studies. Right. So we can calculate IQV for each campus to determine which is greater. Okay, so here we can understand that the value of K, and we can summarize the categories and also find the IQV. And just substitute those values and then you find out the values. Right. Fine. So this is just a very small thing to just make sure that we just warm up before going to some more activities, okay, pertaining to our lab. So how is everyone coping? Everything okay? Can we go with some lab activities? Plan is fine. Option is fine. Fine, good. Okay, so transfers also increased. Fine. From 30 to 43. Okay, hope there's no questions, right? Any questions? Everything is fine, right? Okay. So maybe I post some questions over here, okay, so that we can start the activity for now. give me a second. Okay, I just want to upload it here. I'll share the screen. Right, so this is uploaded activity for now. Okay, so everyone can download this document, and we are going to start making all these things completed now. I wanted you to also get your screenshots in the chat so that we know that you are also progressing very well, right? Can we do that? Okay, so this is actually when you're having a normal values, okay, normalized values. So when you have 0, right? So when you're having 0, it means there is no dispersion or variety, right? When you have 1, it means most or maximum dispersion, right? So in case we have normalized value, that's what we're trying to put here. Illusion. So it's not the case always, not interpretation of always, but this was a case of normalized values. Okay. Is everyone able to download the data pre-processing activity? Yes, Lucian, is it okay? People get it? Okay. Chime. Okay, how about others? Any doubt in this code? First one, sample data set. Are we getting the code done? Okay, fine. Leave log. Lucian did not answer. Lucian, are you able to get what was my justification? What is your understanding here? Okay. Have some question here. Okay. Delete column and row. What is the need to be deleted? Okay. So this is open question, which means that we just wanted to know that we are able to delete one particular column. Okay. And any particular row based on our clause. Okay. So what clause will you use when you want to delete?
Drop.
Yeah, drop. Okay, but we can also use when you want to use a particular row, you need to select that particular row, right? So you can use if then. Okay. Okay. So can we go with the so who has completed the first one? You were able to create the data set. Okay, very good. How many of you got the first one? You can put your output here. Very good. Okay, most of you got the answers. Fine. Can any one of you paste the code here so we can use it for the hands-on? Okay, very good. No, Sabrina. Thank you. Our program is the program. Right. So we have age, gender, height, and weight. Age, gender, height, and weight. Okay, very good. Executing fine. So now we have the data set. Rock print. Data equal to student. Run. Okay. So perform log transformation on the age attribute. Okay. Are we able to do that? Perform log transform. Okay. So what do? You just take the log of that particular variable. Hope everybody's getting this. Okay, very good. How about others? So what you do, you just take the log of that particular age, because our question is perform log transformation on the age attribute, right? We want to get log of this particular age attribute. So what do you say? We just create a new variable called log underscore age, and this variable will have log of age, right? So once we set the data that we already created, right? So this data will already be populated in this student1 along with the particular log age, right? So everybody getting this? Okay, good.
Sir,
Yes.
I have a question. For the log that we use, if I use the calculators, it shows a 1.113 something, but I get in the SAS is 2.5 something.
Okay. Log of 13. Check it out. Okay, did you use any base log?
I think standard one is base 10, right?
Okay.
I get the same answer as Sir, but I just curious, then I go to my scientific calculator and get the different numbers. Yeah.
Okay, good. So we'll try to digest that and we'll check it out. No issues. So hope you are getting this. I'll just post it here. The reason why we are getting this. Okay.
Got it, Sir.
Okay, thank you.
So in this case, we need to put the log 10 rather than putting the log only.
Yes. You just try that, get it. Because that is the reason why we are getting this confusion. data. Very good. Okay, very good. Okay, so the question here is why there is no big concern about what type of log we are taking into consideration. Is my question clear?
Yes, sir. I think the scale is the same. It's like just the ratio added. So you use log base E or base 10, actually we get the same ratio increase because like increase by 10 or decrease by 10.
Yes, correct. Thank you, Chai. So that is the reason why we are not much worried about whether we are talking about what type of a base we are taking into consideration. Once we are having one particular function with this particular log, okay, all the data sets is going to follow the same. Okay, so irrespective of what type of a log it is, we are just trying to bring it into one particular normalized form. Okay, mostly everything is mainly for the feature engineering. And that is the reason why I was justifying the reason, okay, whether you want to go for normalization or standardization. Okay, it's all once again depending on your model. Right? So that worry is too much only when you go with the modeling, not during the data management. Right. Hope I'm giving some clarity on that.
Yeah, yes, sir. Understood.
Thank you, Chai. How about others? Are we getting some sort of a clarity here? What is the discussion and how are we progressing on the discussion? So these are some active blocks happening side. That's really good. Really good. Oh, I missed something here from Wong. Because sometimes even when you talk about normalization or standardization, okay, in some language we talk about data transformation, which uses functions and all those things. So better not to get too confused about these terms. Yeah. Thank you, Wong. Very good. Yes, can. No issues. Okay. The reason why I'm not sharing, so that I just want some to also progress. Okay. Hope this particular code is there. So we just printed that, and now we are just trying to get the log details. I paste the content here. So this is about the log. Okay. Okay. Now regarding the next question, how are we getting this particular delete column and rows? Okay. So we're not going to do both now. Okay. First we're trying to delete column, delete one column, right? After that we can delete any particular row. So both are different exercise. Delete any particular column. That is one exercise. Another exercise is delete a particular row. I just give some few minutes for your understanding, and then we'll make it. Okay, Chai is getting it. Very good.